For me, it's always been the process of discovery itself, actually. That uncovering new things, a new realization in science, cracking a particular problem. That moment of discovery, I think, has always been the greatest and most enjoyable thing for me, I think. And I think it's as simple as that. My research deals essentially with trying to uncover new types of reactivity and using that reactivity to make new classes of molecules or to overcome synthetic problems in materials chemistry. So I am a molecular chemist, so I deal with making molecules. So a lot of what I do, for example, is making molecules to make materials, and that can extend to areas such as battery chemistry, photocells for solar cells, and catalysis. So those are generally the areas of practical use, but my work extends from the domains of the more ethereal, how can we make a particular unusual kind of compound, and what synthetic methods do we need to use to develop to make those compounds, to developing synthetic methods to make materials, essentially. A big challenge in synthetic inorganic chemistry is to develop the sort of systematic approaches that are a commonplace in organic chemistry. So whereas in organic chemistry there are defined sets of reactions you could use to make a target molecule, your pathway requires a lot more investigation in inorganic chemistry, where the elements are a lot more varied across the periodic table. We're developing new types of ligands which are metal-based for catalysis. We collaborate a lot in Germany and in China on that area. Photodiodes for measuring small amounts of light from medical scanners. In the battery area, we're developing coatings for electrodes which will reduce their rate of decomposition. So you get longer life batteries. And that allows, hopefully will allow us, because we're working on it right now, to extend the lifetime of batteries such that you can get more miles from a charge, essentially, with novel types of battery materials. I'm also initiating a program with a local company, a solar cell company, where we're looking at a particular effect called down conversion. In other areas, we've looked at making types of industrial catalysts, for example, for isotactic or syndiotactic polymerization of alkenes, and new synthetic methods towards that. In my group, we work on a lot of different programs, and it's not uncommon for all of my group at a particular time, each of them having an individual project which is not directly related to the other person beside them. But the theme in what they're doing is to develop new types of synthetic methodologies which will overcome either fundamental problems or problems associated with applications. We do socialize quite a lot, actually, and there's a lot of socializing within my group. We do have a group entertainment officer who deals with these sorts of things. So it could be as simple as going out for the evening. We have a good Christmas party, and we generally socialise a reasonable amount. I'm unusual in my family because I'm not actually an artist or a woodworker, and I went to university at Strathclyde in Glasgow. I was actually brought up in Scotland, as you can tell from my accent. I moved down to Cambridge after my degree there to do my PhD here. I think things have changed a lot in Cambridge as far as it's modernised a lot in its attitudes. It's a modern, forward-thinking university. Coming from outside Cambridge 31 years ago, I found it difficult. I think the expectation was that everybody was going to be super brilliant, and there are some super brilliant people here, but I think if you're admitted to Cambridge University at any level, it's highly likely you're going to be competitive with the people that are here.